This screencast is going to look at what you need to put in a folio when you hand it up. It's mainly targeted at the statistics folio, but it can be applied to all the other ones. When you do a folio, it's really important that you cover these things in it. It's kind of like a format that you need to set up and you need to go through the steps. You need a title page, you need a contents page, an introduction, calculations, analysis, conclusion, and appendices. Notice that there's no method in there because the method should be evident in your calculations in the way in which you kind of solved it. So there's no point saying I'm going to do this, then this, then this. So let's look at each bit individually. Title page, very simple. Just have your name on it, the topic that you're covering, your SACE number, and your home class, and that's about it. You could put an image there if you want, as long as the image would lead to what you're investigating or what the reader is about to see. Okay, it's no big deal. The contents page should probably be done at the end, and this is so that the reader can look at the contents page, work out where everything is, flick back and forward until they need to find it. So just be aware that that needs to be there as well. It's part of the communication things that we look for. So a contents page and with the page numbers of where everything is. You can use the headings and things like that inside Word and inside Google, so then it actually creates a table of contents for you, and that might be the easiest way to do it, but it's up to you. The introduction is quite important because it sets up the task for the reader, and you've got to assume that the person who is reading this task has no idea about what you're doing, so you've got to make it really clear. It's kind of where you repeat the question or you repeat the situation that you've been given. You need to put it in your own words, and it needs to be clear and concise. You need to give an overview of the problem that you're doing, that you've got and how you're investigating it. Make sure you cover the key points in the question sheet. If there's a story behind it, you might want to put that into the introduction as well. Indicate if you're going to investigate more aspects associated with this problem. So for this one here, you're seeing if there's a relationship between protein and egg, weight and protein, and the lifespan of chickens. But then you might say, I'm also going to explore whether it's economically viable to operate with the optimum amount of protein added to the feed. So then you're telling the reader that you're going to extend it. And then summarise how you're going to do this. I'm going to be using the strength of correlation. I'll be drawing graphs. I'll be tabulating my data, and then I'll be drawing conclusions. So the person reading it will see that they will read that that's what's going to happen, so they can be able to anticipate it when they actually go through the task. When you get to calculations, this is where you show the work that you have done. Now, if it's repeated calculations, things over and over and over again, I would summarise those findings in a table and put the calculations in the appendices. But for this project, you can show us how you find the sample size. You can then put the graphs in there, and you can go from there. So the really important things for the calculations for this project is that sample size. First thing is discuss the primary data, which is those big lists of 900 pieces of data. Discuss where that you've been given that data that's been recorded, and you have to find a sample from that. And then you can show how you found your sample size, and maybe even discuss the process you used to select your sample size, but then also to select your sample so that bias was removed. And then you can show you're working out with that as well. Okay, that's not too bad. The next section you'll probably be doing in this one is doing graphs, and then those graphs are your scatter plots. And we've done them in Excel and brought them across. So your scatter plot, you'll want to put them there, and you want to have them with the line of best fit there and your R squared. And you might want to talk about how the strength and direction of those scatter plots, or those correlations that you've got, and then talk about outliers and removing them and show the difference that's happened. Okay, your R squared should change. So you could nearly put a table there saying R squared before outliers removed, R squared after, so you can actually show that that's actually gone up, okay? Because otherwise you're going to be repeating, I've taken this out and R squared has gone from 0.1 to 0.4, and you do that 3 or 4 times, it's very boring to read. But a summary of those things in a table is quite good. It may not be necessary because you might only have a couple of calculations, but if you've got lots of calculations and things like that, it's really good to put them into a table. And then once you've pulled the outliers out and you've got your R squareds there, you can talk about whether this data is now appropriate to use to make calculations and predictions and extrapolate your data. Okay, so you've actually gone through that process. So you've talked about your method as well, but you've got that information in your graphs. The correlation and your correlation is really important. If you want to extrapolate and interpolate your data, this is where you get your equations of the line, and what you want to do is substitute values in for x to work out what y would be. So you might say my protein is going to be this. This is how big my egg will be, and this is how long the chicken will last for. And you can do it around the other way as well. I want my eggs to be this big. How much protein do I have to put in? Cool. And then you can say how long will they live for if I do that. So you're doing both ways of that, substituting into that formula. And to use that one for I want my eggs to be this big, you might want to be able to get data from, say, a supermarket where there's eggs on sale there, and you might go, oh, it has to be this many grams, therefore this is how much protein I've got. Fantastic, but the chickens die in 2 weeks. So, you know what I mean? You actually are looking at exploring that more, and that's in your calculations and your extrapolation and interpolation. And that can be an extension as well. The idea of finding the ultimate lifespan and weight of an egg, and you do that by doing simultaneous equations and making the equations equal each other, and you'll get a value for x, and that will be how much protein you've got to add, and then you can work out how long they live for and how big the eggs are. And once again, you can talk about whether that's economically viable to occur. So you've taken is there a relationship between the data, and then you're moving to the next step and saying, okay, if there is a relationship, what predictions and things can I make from this data to make it better for the reader and also interpret what I'm getting. So that's kind of the extension bit to this kind of project if you wanted to go down that way, and that all sits inside calculations. Now, because you can comment as you go through with your calculations, normally the analysis tends to happen organically as you work through, but it's really good to try to interpret the mathematics that you've done and explain to the reader what you've discussed. Sometimes you've done it as you've flowed through, but make sure you mention what the calculations have shown you and why you've done it. Like, has it made your sample better by taking out the outliers? And mention what you found in relation to answering the question. So this is now showing me that there is a strong relationship between this and that, so Farmer Bob is correct. Okay, so you just got to keep on linking it back. So analysing mathematics is explaining to the reader what this is showing you and why that has occurred. What it's showing you and why that's occurred. Make it really simple like that, and make it clear so when you read it, you go, that's exactly right. So anyone should be able to read it and see what's going on there. As you have done that through with your calculations, this may not be very long. Now, the last bit that you need to then do is looking at the conclusion. The conclusion is then bringing it all together. Now, sometimes you've mentioned that in your calculations and your analysis, and so some people think, oh, I'm just repeating it. But your conclusion is drawing it together and answering that question that you started with. So you're looking at saying, this is what I have found, this is what it shows me in relation to the question, this is who is right. So you might find that one is right or one isn't right. You might find that Chicken Little is right. So if you want to have big eggs, you're going to kill the chickens, which isn't going to be appropriate. But you need to tell the reader what you found in the context of the question based on the data that you've got. And if you have done an extension, you can then say, but I have found that this amount of protein will give me this size eggs and this size chicken weight, and that's pretty good because that will help the chickens live, and it'll be positive for the company because they're long enough and blah, blah, blah. And you might want to do some more research into how long a chicken lives for and how big the eggs are to be able to kind of argue this point in your conclusion, and you could probably mention that in the analysis as well. The last thing you can have in a project, and it may not be in this one as much as possible, is the appendices. Now, the appendices is where you put all those repeated calculations if you need to. So if you've got some information on chicken, how long a chicken lives for because you've done some research, then that can go in there as well. It's in the appendices. You refer to it in your discussions, but you don't need people to read through all the stuff with what you've got. I would be putting screenshots of your of the spreadsheets that you've had. Put them in there so the reader can go, oh, there's the screen, there's the spreadsheets. I can see that they've done the work. I don't need to have all the the 900 pieces of data there because I know you've been given that. I just need to know what you've been working with. So a couple of screenshots of that. When you've got full data, then when you've taken some data out for the sample size and those kind of things. So it's just evident that you've done it, and just do a screenshot in Excel and just drop it into your Google Doc. That'll be fine. If you have done any referencing at all, you need to reference correctly and make sure you can do have a bibliography at the end if you have looked at anything that has helped you with this project. So that's it. That's the way in which you put the whole lot together to have a folio, and in particular how the stats folio should go like. Excellent.